is liquid, is subcooled, and at the right hand side everything is superheated and is in vapor. Yeah? You've got a horizontal axle with very vertical lines that never change, and it gives you the pressure. And you've got a, excuse me, that's a vertical one, and then you've got a horizontal axle which is giving you the energy content. As we saw, it's expressed in enthalpy or kilojoule per kilogram. Okay, that's a deviation of calorie or of watt or of BTU. There's an international system uses joule. Yeah. This is your saturation line. This is your critical point. This is your condensation line. I think in American they call it the dew point. And this is your superheat, and it's going to be the, no, that's the dew and that's a bubble. Yeah, so, yeah, anyway, I might be wrong with the terms here. In Europe we use different terms. But anyway, again, to the right hand side of the dome, the refrigerant is in vapor. To the left hand side of the dome, the refrigerant is in liquid. And in the middle is gradually transforming from liquid to vapor as I evaporate, or from vapor all the way to liquid as we condensate. So if we start with the right hand side, you've got 100% vapor line, then I've got the saturation line, and in here I've got 99% liquid content, 1% vapor, and as we move and the evaporation process completes, I will have at the end, before the saturation line, I will be 99% vapor and 1% liquid, yeah? And that's going to illustrate the outlet of your evaporator. Once it goes over the saturation line, I'm in 100% liquid, in vapor, I'm sorry. The vapor doesn't undergo change of state, but it increases in temperature with respect to the saturation temperature, and that is where I'm going to calculate my superheat. Typically, on an air conditioning system, your superheat is going to be high, 10 to 15 Celsius, and whereas on a refrigeration system, the superheat is going to be low, 5K. Okay, let's speak about Kelvin. It's only 5K. You need a big superheat on an air conditioning system also because you're going to take out the humidity from the air as well. So if I will start looking at the components, you can see this is your compressor line. Yeah? Again, I told you the compressor purpose is to compress refrigerant, to add energy, and with the energy increase the pressure and consequently the temperature, because we need higher temperature. So there is the energy, work of energy, this between there and there, is going to be about 8, from here to here is going to be, let's say it's about 60 kilojoule of energy in the compressor. Yeah? So I'm